Well, hello, mathletes. Um, so today we're going to be talking about section 6.1 in your book, and that's the introduction to functions. Now, before we start talking about functions, we have to talk about relations a little bit. And a relation is any set of ordered pairs. Now remember, an ordered pair is just a point, right? It's the usual XY coordinate we're used to. So a relation is just some collection of those. Let me give you a couple of examples, and I'm going to give them names. So we're going to call the relation F, and F contains the point 0, 3, 1, 6, 2, 4, negative 1, 1, and negative 2, negative 2. Now with this one, there's absolutely no rhyme or reason. These points, the connection between the X and the Y coordinate are completely random. I just pulled them out of the air. It's just a collection of points, which is what makes it a relation. Let me give you another one here. So G is the point 4, 5, negative 2, 3, 3, 2, 1, 4, and 4, negative 3, right? So these are both relations. They're a collection of points. It doesn't have to be 5 points. I chose 5 because it's a nice number, but it could be, 1 point. It could be a million different points, but it's just a collection. In fact, it could be an infinite number of points for that matter, but it's just a collection of points. Now, a relation is a function if each value of the independent variable, or the x value, right? The independent variable are your x values or your inputs. Has a unique value of the dependent variable assigned to it. Let's try my spelling a little bit better here. Now, the dependent variable would be your y values, right? So those are your output values. So basically what that's saying in English, so to speak, is that when you plug something in, right, when you pick an x value, there can only be one y value that's associated with it. So if we go over here and let's say we want to look at the function f. Now, remember, these coordinates, you can actually think of them in terms of an input and an output. Oops. Let's try that again because I apparently can't write that high. Right, so let's try this again. So a coordinate, normally we think of it in terms of an xy coordinate, but really this is an input and an output, right? And when we talk about evaluating functions, because we have actually dealt with functions before, you take f of the input and that gives you the output. And so in this case, all of these x values are my inputs. And so basically, if I look at f of 0, I get 3. f of 1, oops, I don't need that comma there, right? F of 1 gives me 6. F of 2 will give me 4. And so you can see this is what this really is just a mapping of where things go. F of -1 will give me 1. And f of, let's see here, what's the other one? -2 will give me -2. Right? And you notice there's no confusion about what's coming out of any one of these. All I have to do is look, and I can see what the output value is. Now, each one of these was single. Now, just to make a little more room here, I'm going to go ahead and erase this. And let's look at G. So, right, if I just started picking things and said, oh, what about G of -2? Well, G of -2 is 3. I can see that right there. G of 3 is equal to 2. And you notice again, we're not doing any computation. We're just looking at what the function says the output is, because that's what it is. It's just an assignment of an output to an input. G of 1 is equal to 4, but we have this issue here. G of 4, right? It's here, and I have a 5. But I also have to have it listed over here, and it gives me a -3 as well. And so there's a little bit of confusion about what comes out of this thing, right? We're wondering, is this a 5 or is this a -3? As soon as you have this situation, right, as soon as you have two different outputs for the same input, that means G is not a function, right? So we know right away G is not a function, and it's because 4 maps to two different things. 4 goes to 5, but 4 also goes to -3. Mathematicians hate confusion, right? So if it's causing confusion on the output, then we can't call it a function, right? And so that's how you tell if something is a function as far as that goes. Now keep in mind, these things can also be what do you call them? Organized different ways, right? So if I'm looking at the function f, the 0.03 could also be organized this way. We've seen this before. The 0.16 could be organized this way. The 0.24 could be organized this way. Could be organized this way. Right? We could write it this way. Another organization of this, let me scoot that over a little bit. Sometimes you see it organized this way, right? X, f of x. So my x values, oh, -1 comes first, right? Go on this line, and the y values that go along with them go down here, right? Now, if you're given these things directly as points, right? You're not given any rule whatsoever. Then the only things you know that you can plug in here are these x values right here. And we're going to see this in a couple of different situations here. But I'm going to give you one more definition. The domain of a function is the set of all possible inputs. So in this particular example, the domain would be the set 0, 1, 2, -1, -2. right? Those are all the possible inputs. Sometimes, in fact, most of the functions we look at, the domain's going to be all real numbers. But a lot of the time in statistics, you're only interested in certain values, and so you restrict your domain down to those certain values. Now, one more thing, right? Remember that a function, if it has two outputs for a single x value or a single input, then, well, excuse me, a relation, if it has two values for a single x value or a single input, it has two y values for that, excuse me. Boy, I can't talk this morning. Then it's not a function. And so if we're looking at a graph, right, we want to know how we can tell if a particular y value, or excuse me, a particular x value has two different y values tied to it. One of the ways we can do this, in fact, let me just go ahead and draw something that's not a function, is the vertical line test. Because if I pick an x value, right, let's say that's an x value, and I want to know what the y values are, I have two of them is the problem. I have a y value here that goes along with that x value, and I also have a y value here that goes along with that x value. And so I have two output values for the same input value. So one of the things you can do if you're just looking at a function or looking at a relation and trying to tell if it's a function is the vertical line test. Right? And the vertical line test is basically if you can draw a vertical line on your graph so that it hits the relation at more than one point, then it is not a function. So this particular relation that I have drawn here, it's a circle, there's a ton of points that I can draw vertical lines through and hit more than one, right? I could draw a vertical line here, here, here. All of these hit 2 points or more, right? It could be 3, it could be 4. So if I can hit more than 1 point with a vertical line, it's not a function. You know, and if I want to take a look at a different graph here, let's go ahead and look at another one. Let's say I have something that looks like this. Right? And I want to know if this is a function. At least from what is drawn here, you notice no matter which vertical line I draw, I'm only intersecting the graph of the function of the relation at 1 point. I never hit more than one when I draw a vertical line. And so because of that, this is a function. So this guy up here, because I'm hitting 2 points, right? I'm hitting there and there. This is not a function. This one, the one below it, it doesn't matter where I draw a vertical line. I can only hit 1 point. So this one is a function. Okay, so functions basically are there. The reason we have that definition, we try to force things to be functions, is so that there's no confusion. You want one and only one output for each possible input as you go through this. All right, so this concludes the first video, and we'll pick up a little bit more in the next one.